Okay, this is a hello testing. All right. This is student when I was recording. This is a Levenshtein distance spell checker sort of program. So Levenshtein distance is a nice mathematical definition, sort of resembles, it does resemble a piecewise function, but it is defined in terms of itself. I haven't bothered with trying to understand exactly what's going on here, but it's recursive. If you transform this into code and have a simple version such as this, so here's the function header with the two arguments, string A and B. I'm using A and B just because that's what the Wikipedia article uses, and I didn't want to screw myself up with using string one and string two as the variable names. So we've got Michaela and Michaela. To go back to what motivated this. How different is Michaela from the Naya? Okay, so if we, how many edits do we have to make to the characters of one of these to get the other? We replace the N with a K, we replace I with an A, and then we insert an L. So it seems like we got 3 or 4 operations we have to do. The Levenshtein distance is a minimum. It returns the minimum number of edits. And you can see a typical human, I think, in some cases, making one or possibly two too many edits, um, and not taking the optimal approach to the solution to convert one string S1 into another string S2. Anyways, just to demonstrate to some extent what's going on here, or to demonstrate that this function works without bothering to obsess over its definition. Quite a few recursive calls, which was really surprising to me. I haven't unraveled that, but the max possible distance between the two strings is the length of the longer string, which is Michaela. 7 characters there. The edit distance is 3. So if a person were to tell you that Michaela is not even close to Manaya, I think they would be wrong, because what does not even close mean? Um, if the furthest possible distance is 7 characters and you are less than half of the maximum possible difference, I think you should be called more close than you are far away to getting their name wrong. Anyways, this has some input, some usefulness in spell checking, as a person could see in the Wikipedia article. Here it says spell check, and at some point in here, or in the other article on string metrics. But if you type in something into Google, like SHITR shooter, and you meant to type in shirt, how is it that Google does this? Knows what you're probably talking about. If you misspell a word, and more commonly in a word processing software like Microsoft Word or Google Docs, how does it make suggestions on what you might have been wanting to spell? And that's what I've attempted to do here in this project, which is Levenshtein with dictionary lookup, which is sort of a simple spell checker. So I've read in dictionary words. It's a text file, which we saw a minute ago, containing 25,000 words. Aardvark arg, which is an onomatopoeia word, a sound word. I think that's what that means. Abandonment, abandons, blah, 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 all the way. It's a text file full of about 25,000 words. Okay, so we read that in and stored it in a vector of words, and then we calculate the Levenshtein distance, but I do some filters here. I get words because this recursive function, evidently it's quite expensive because my computer, which is a solid computer, is taking a while to check through the entire dictionary, which I was a little bit surprised by. Maybe the iterative version of calculating the Levenshtein distance will be less less computationally expensive. I'll be curious to do a comparison there at some point. But it gets into two-dimensional arrays, which some people find unpleasant, I suppose, myself included to some extent. Let's see. Levenshtein distance calls minimum function here, but it doesn't call itself. So at least not jumping out at me. So that might, it'll be a neat thing to look into. Anywho, um, at the moment I'm doing these, I'm doing these filters. I say loop through the words in the dictionary of 25,000 words approximately, get the difference in the number of characters, but first check and see does the is the zeroth character, that is the first character of each the start word, equal, is it the same as in the dictionary word? Because I suppose it's unlikely that somebody would misspell a word and start the word with the wrong character. And the absolute value of the difference between the number of characters, which is passed as an argument here, it needs to be less than um, it needs to be less than some limit that's specified in the main program, which I set to 3 here. So examples, if somebody wants to spell the word character and they only spell CAT, that won't get caught because CAT's length is 3 and character's length is 8 or 9 or whatever. And 8 minus 9 is 5, which exceeds 3. So I get close length words by calling some function, a simple function that loops through all the words in the dictionary, gets the difference in the number of characters, and yeah, also added that first character bit, so I should rename the function. Okay, so just to demonstrate this, this also takes a while. This is a misspelled word. Absence is spelled with a C at the second position. It's quite a good example. I'm sure students have done this before. So first I display all of the words that begin with the same character, quite a few words within lengths within 3, with lengths within 3 of absence. So aardvark is within 3 of absence, so is arg. So okay, aback is also, and they all begin with A. Quite a few words that are gonna have to be looked through here. So press any key to continue is just a pause. Press any key to continue, and it's gonna take a second. So absence will hopefully, all right, it was not terribly slow. Absence is most similar to the following 10 words. Absence, spelled correctly, the S has been replaced with a C as an edit distance of 1. Absences with an edit distance of 2. Absent, which is a nice example, with an edit distance of 2. Absentee, and then we get into things that are more dissimilar as humans know. At least the meanings of these are very different. Abreast is not at all similar in its meaning to absence. Edit distance is 3. Okay, abreast, so it's kind of neat to see. Yeah, appease. Okay, edit distance of 3. Anyways, a nice approach to do this in class might be just looking up commonly misspelled words on dictionary.com, for instance. That was my first example. Accommodate, not disaccommodate, and C's and M's, like how many of each. This is obviously wrong to my eye. So let's try this case. And I think with longer words, my recursive function here kind of has a meltdown because the this tail and this tail business is getting substrings, and it's eventually hitting a recursive case, a base case, the one plus standard min of x, y, and z. These things I didn't look into, but let's the string length is longer, so it'll have less matches. Maybe I think the commonly occurring most common word length in the English alphabet is like 8 characters or thereabouts. It's another interesting thing to look into. So we got all these possible matches, approximation, arachnids, arbitrary, etc., etc. So this might take a minute. Before I did any culling on this algorithm with getting the same first character of the two words and checking that word lengths are the same within 3 characters, it took for I forget what my input was, but for like 5 or 6 letter words, it took a couple of minutes actually. So interesting, interesting to look into. And in this case, the top match might not be the correctly spelled word. Yeah, I have no idea how long this will take, so I might pause the. Might take prohibitively long, like until next year. Oh, and I paused the recording for a minute here and do other things. And the time right now is 5:50 approximately. So okay, not surprisingly, I suppose that was taking more than a few minutes. It didn't resolve, so I added a counter variable to the most expensive method in this program. It uses a multi-map, which allows multiple instances of the same edit distance to be mapped to a certain string. Like an example of this is cat to hat and cat to mat, or whatever direction the arrow needs to go here. If a person types hat and they mean to type cat, or they type mat and they mean to type cat, the edit distance of both hat and cat to hat and mat to cat is 1. There is a website for this, not surprisingly. If you look up Levenshtein distance calculator, their default example is book and back. If you go cat to hat or hat to cat, hat to cat is 1, it's 1 replacement or 1 substitution, as the Wikipedia article refers to it. Hat to hate involves an insertion at the end, not an insertion at the middle, which insertion makes me think in the middle. Deletion is hate to hat, involving deletion, a single operation or remove all the character E. Anyways, you get what I'm talking about, I'm sure. Yeah, that's why a multi-map is necessary here. Maps require unique keys. Multi-maps are not limited in that way. From my understanding, I haven't dived into that much yet. Okay, so I set up um, Finnish words is not words like in Norway or whatnot, or Sweden, but Finnish words is the close length words. Okay, so that's getting called correctly. But I set up a counter to do a little update and display the top match so far while the program is running. And the word again is accommodate, misspelled with an A here instead of an O. And there are, let's see, looks like scrolling here, there are more than 100 words that have the correct length. It would be nice to go ahead and display that length, I suppose. Where did I put putting how many of these exist? How many of these exist? It's 532. So I should get an update every, let me do an update every 10, I suppose. Every 10 iterations because it was taking so long to do 532. So if counter mod 10 is equal to 0, then display the top match so far. Taking a long time. Even to get to the first 10. Okay, there's one. Top match is abdominal with an edit distance of 7. Jesus Christ. Abnormality. What was our base word? Start word. This is nicer. And we're seeing replacements. Yeah, 6511 accommodate. Okay, there's it. There it is. Accommodate is still the top match, and it's always going to be the top match. So it's not necessarily the case that any word with an edit distance of 1 is going to be the correct replacement, like in the cat, hat, mat situation. Is an uncommon misspelling. And then after 10, 20, 30, 40, 50, like 100, we're hitting a wall. And not getting an update is definitely not a well-written program. I didn't take a lot of time or care with it, as I usually don't. Anyways, this is kind of neat to see, obviously, in my opinion. So I'll just leave it at that.